Hey everyone, welcome back. In this portion of the video tutorial series, Coding Your Own Rat in the Delphi Language, we're going to be covering networking. So we're going to be covering sockets. So the best way I think we can do this is just for you to watch and for me to draw and explain. So, but before we get into that, let's talk about clients and servers, because this is going to be very important for you. So let's grab ourselves a group box and slap her down and slap her down. All right, cool. So now we have two of these. Let's go ahead and bring this one about midway. Bring this one about the same. And drag this up. So in Delphi, and in any language in the world, and any computer in the world for that matter, we have clients and we have servers. So here, let's give this thing a little dark theme. That way we're not all blinded by this shit. How about impressive dark, square edition? Okay, cool. So all about sockets. Okay, so on the client side, let's talk about all the different sockets, or at least a good portion of them in Delphi that we can really mess with. All right. So here is a basic T-WinSock or WinSock wrapper for Delphi. It's a legacy-based socket, and we're going to get the corresponding socket to that, which is a server. So as you can see, this essentially connects to this. So the client socket connects to the server socket. And then we're going to go and grab some more stuff. This is a Netcom 7 socket. So these sockets are very highly power, and they are TCP as well. So that is to say that this socket goes to this socket. You see that? So these are all TCP sockets, so they're the same tech, same stuff, but the way they handle their connections are different. So let's keep going, just for shits and gigs, so you guys can kind of understand a bit. Let's go with a TCP server, and let's go with a TCP client, which will be this one. So these two go together. And then we have, we're going to have the TCP server from Indy. These are blocking sockets. And we are going to do TCP client, which will be right here. Then we'll have the command TCP client and the command TCP server. Same thing. They're all together. These can be easily used. Like, you can see how many sockets we have in Delphi. It's absolutely fucking unreal. You have every single one of these sockets. I mean, it is literally fucking unreal. Look at that. Probably 20,000 lines of code already written for you to drag and drop. So here's an IRC client and an IRC server for chatting, already written for you and already programmed. Isn't that fucking unreal? Can't get that in any other language, that's for damn sure. Guys, I could keep going and going and going and going. More than the Energizer Bunny. We can whoop his ass. Yeah, it'll take me 50 billion years to go through all this shit. Basically, Delphi is the god of all languages. We literally have everything at our fingertips, and we don't have to learn jack shit because we're gods. We're just done. Bam, boom, bingo, bing, bada, boom. We're done. So these are all TCP, but I do also want to cover a couple UDPs. So let's look up UDP. So I'll kind of separate these to the bottom. This is a UDP client, UDP server. And then here, I'll kind of pull up on that a little bit. And then we've also got a lot of other stuff. We've got, for example, this is the Clever Internet Suite. This is a UDP client and also a UDP server. So these are UDPs. These are all TCP related up here. And they connect to each other. The reason I wanted to show you guys all this stuff is that I would like you to see how simple it is to work with these things. So let me go here. This is also a UDP server for Netcom, and I'll just paste it kind of over here. And then there's also the client, which goes right here corresponding to that. So this client uses this. Now you're probably wondering, well, Bitmaster, with all this shit, I mean, is it possible to make this one communicate with this one, and this one, or this one to communicate with this one, and 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 this one to communicate with, intertwine them? Yes, it is. It's entirely possible, absolutely. Because once you have a client based on a certain protocol, it can act and respond to anything and everything from any other socket, really on any different other protocol. It's just going to be a bitch to program, but you can make it happen. Now, when I say it's a bitch to program, in some cases it is, in some cases it isn't. I mean, see, this one doesn't, I don't think this one handles Unicode and encoded strings by default. Nor does this one. So you can make these communicate, but some of these other ones are highly advanced, and they actually handle a lot of different things in many different ways. So you would just have to learn how they're written. You'd have to look at their source, which you can do, by the way, and you would have to figure it out. But that's not really why we're here. We're here to talk about sockets and what they mean, what they are. Because you guys, I'm pretending you guys are total beginners and you've never written networking-based stuff before. So, basically, in terms of our wrap project, this is your candy laid out on your table, right? And you just got to pick which candy flavor you like. So, I mean, ultimately, you can code a rat with pretty much any of these. Literally, any of them. Including the IRC. Hell, you could make an IRC rat. So the point comes in to where, you have to decide what you want, okay? So these are extremely old, like they're legacy-based socket components, but they do work, and I mean, they're stable, I guess. I mean, as long as you're making them stable in your code, I suppose. But they can be blocking or non-blocking, which is really cool. Because see, you can change the client type and the server type here, blocking to non-blocking. So a lot of you guys are probably thinking, wow, that's great. What's the point of blocking versus non-blocking? Well, we're going to get to that. But for now, let me show you this. Every single client and server in the world has only one or two jobs to do. The client's job is to essentially connect to a server and send and receive commands. A server's job is to wait and listen for multiple clients to connect in and keep a virtualized list of them in RAM so it can loop through and send commands to and get commands from them. So how does this work? Well, the clients have to connect to a server, but how do they do this? They connect to a server by using a host or an IP address, right? And a port number. So there's two pieces of information to connect a client to a server, an IP address and a port number. Once the IP address and port number are entered into the client can attempt to establish a TCP connection to the server. The server can then get that request and either accept it or decline it. So once you kind of have that basic understanding, you'll see that the servers, all they do is listen on a port. They don't have to have an IP address, just a port number to listen on. That's it. So check this out. So remember how I just showed you on this socket, for example, this client socket? It's the host and the port. And the server is just going to listen on the port. So if the client is trying to connect in on localhost and trying to connect in on port 33, that means that the server has to listen on port, what's that, guys? 33. Right, exactly. So now the client will be connecting in on localhost, or you can type in the word localhost, like that, or 127.0.0.1, which is localhost. Localhost, the word, resolves to 127.0.0.1. So we can leave it either or. But this will connect to the server. The server will accept and hold that client in memory. Now, let's move on to the next, and you're going to see a very huge similarities between these different libraries. So, for example, this library for Netcom, you can go to the port numbers right here. The host is right here. So guess what? Localhost. And what was the port number? Oh, 33. Okay, great. then you can also do the exact same thing. However, this socket has some really cool stuff in it. There's actually a compression-based thing where you can do default, fastest, max, whatever. There's also an encryption where you can actually encrypt all data traffic going through the sockets. Oh wow, it's got lots of stuff too. It's got triple des, blowfish, cast des, ice, RC6, 542. It's got teeth and ice, two fish, and blowfish. Wow, amazing. So, you got all these you can use, which personally, these are really not all that great, if I'm being honest with you. 3des is great. That's actually not a bad one. But the compression, you can do fastest, none, max, whatever. And then you have your encryption key, which this is what you would encrypt all your shit with. That's the key that you would encrypt with to encrypt all your data in triple des. So there's all that. This is an advanced library which has some really cool advanced features. But the main point is it still has the same two things as these sockets did, which is the host and the port. So as you can clearly see, this client socket is able to connect to this host on this port. And this version of the server for Netcom 7 listens on a port 33. That's all it does. Now, if you set up the encryption, like this encryption, the ET triple des, with no compression, and you have this password, you have to also there ensure that this one has the same exact setup as the other one. It has to have triple des, and the encryption key has to be exactly the same. Otherwise, data will not be sent or received correctly because it will be all scrambled and won't be able to decrypt it properly. So, with that being said and done, the port is 33, and it listens and waits for connections from this. Now you'll notice the same thing here. Oh wow, check it out. It's 127.0.0.1 for to connect to this guy, and we're going to connect on port number 33. And then this guy right here, oh, he's got a port number 33. He listens and waits for sockets to connect on port 33 from clients. Oh, this guy right here, he's got a host right here, local host. And what's the port number? Oh, 33. And this guy right here does the same exact thing. He listens on port number, default port, see that? 33. So then this guy right here, same thing. He's got, he has the port, which is going to be 33. And then the host is going to be localhost. Boom, there you go. Now, some of you guys might be wondering, what's the bound IP and what's the bound port? We'll get to that another time. Basically, it's a little bit slightly advanced, but if you don't know anything about NAT, which stands for Network Address Translation Tables, then you're really not going to get that. But believe it or not, these come in really handy on different sockets that you're trying to perform hole punching with, actually, like through your NAT router and stuff. But we'll talk about that later. So then this one, same thing. I'm not going to continue going, guys. I think I'm about to bore the shit out of you probably with this. This is how simple it is, guys. The client sockets connect to a server using an IP address and a port number. It's that simple. It doesn't get any simpler than that. The server listens on a port number and waits for connections to come in and manages them in memory. That's it. That's literally all it does. The same thing goes for UDP. However, TCP, all of these sockets down to this, all of these are all TCP. And these are UDP, User Datagram Protocol. So TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. Now, TCP, all of these are all connected. Like it's a connection-based protocol. TCP is a connection-based protocol. In other words, it's like a constant stream of traffic. You can think of it like that. But UDP is more like a gun firing off a bullet. The bullet might miss or ricochet or go somewhere it's not supposed to go. So you might not get data. And you might also get data out of order. But TCP doesn't have these problems. TCP is fully connected and has the three-way handshake. So basically, that's pretty much it, guys. So the UDP stuff is the exact same. Here, I'll show you. Like, you can click on these, and you can say that the host is localhost, and the port number is 33. And by the way, the cool part is you can actually use UDP and TCP at the same time. Because they're different protocols, and they can use the same port numbers at the same time, which is pretty cool, right? Because you could be streaming, say, like just basic stuff over TCP, but when you want to stream like people's audio and video and stuff like this and that, when you need high power, like the ability to get stuff really, really super quick, UDP is the best choice because we're just firing off data and hoping it gets there. And instead of TCP, which on the other hand, you know, if something happens to a person's microphone or it gets unplugged from the jack real quick or something happens and you weren't expecting that in your code, you can have a lot of problems with that. With UDP, you don't really much care about exception handling, not really, because you just fire it off, it either gets there or it doesn't. So it's a lot easier to mess with too in program code. So like I said, this can be localhost on 33, and then this one will listen on port 33. And notice that's default port 33 on these. You got to really look at the components, guys. Sometimes components can be a little meh. Like they can have the naming convention of the host port, local port, all this stuff. A lot of this stuff can really confuse people. But usually it's going to be one order of something. Like that's going to be the host, and this is going to be the port, and that's it. And on this one, it's going to be the default port, which kind of threw me for a loop there for a sec. I didn't notice it until I was like, where's the port at? Well, first of all, there's really only one thing here that has the word port in it, and it's the default port. So obviously, that must be the default port for this component, okay? So you can do the same with these. Like this right here, there's a port number, so we can put 33. And then the host right here, so localhost. And then you can go to this one and you can set its port to 33, and the you can do the let's see here, yeah, it just listens on 33. That's great. And you can also set these to be IPv4 or IPv6 for the IP family. It's kind of cool. I actually a buddy of mine actually developed these two components as an addition to the Netcom 7 library. So big shout out to Spawn77 on GitHub. I'll also link his GitHub page down in the video's description. So thank you, buddy. I appreciate you putting UDP into Netcom 7, my favorite socket library. So anyway, all right, moving on. So with all that said and done, let's move on to Excalidraw. So I know I've explained this a little bit, but we're going to kind of take a trip through memory lane, if you will, at least for me anyway. I hope you guys learned something from this. This is very good information, okay? So we're going to talk about DC, okay? So DC stands for direct connection. So let's type that out. So, direct connection. So back in the day, and we're talking way, way back in the day. So guys, back in the day, here, let's go ahead and draw a little kind of diagram here. This will be the World Wide Web, okay? The internet, as we know it, right? Or rather not, since it's old as shit. Okay, so this side will be a computer that's going to be us. And we are labeled as A for the so-called attacker, right? And then on the other side of the globe, let's just say there's some other guy, and this guy's labeled as a V for, you know, potential victim, right? Or whatever it was. So essentially what would happen is we would usually connect to a modem box to connect to the internet, right? So this guy has his own modem box as well, and he connects to the internet as well. Wi-Fi at this time really didn't exist. So, I mean, we had some hubs, maybe some switches, I think, but really no wireless was really a thing. I mean, nobody, or at least it wasn't very big at all. Like, nobody had wireless routers. So everything was done direct connection. So you'd plug directly in and connect to the internet, etc., etc. Because of this, security really wasn't, to be honest with you guys, it really wasn't taken much into consideration, hardly at all. In fact, only, I don't know, probably like different companies probably had security measures in place, but most home users didn't have jack, okay? Because they were literally jacked in. Get it? Da-da-ching, I'm here all week. Okay, so basically what would happen is we, the attacker, would build some sort of a virus, right? In this case, a rat, let's just say that, right? And we would send it through the modem, through the internet, and probably upload it to like a website or something, maybe. So then the potential victim would go online and be browsing the internet, la-di-da-di-da-di-da-di-da-di, and then they would find that on a website and download it back to their machine. When it gets back to their machine, And here, let me kind of control Z this a bit. So we would put it on the website. They would go to the website and download it, and then they would execute it on their computer. We'll put an X for execute, right? And what would happen is that the virus would run hidden, obviously. So we'll just put it down here, like hidden in a block of memory, right? And it would run, and it would be it would act as a server socket. Now, I want you guys to pay very special close attention to this because this is very, very fucking important. So they would act as a server. We would open up our rat on our screen like so. So it would look like this, and you got your little Xy thing and all that crap. So then in here, you would have to type in an IP and a port and click a little button that says connect, and that would connect through the modem, through the internet, through to their computer, and directly be accepted by the server socket, which would then hold you in a list in memory to say you're connected to them. So this is direct connection, and it is extremely old. So keep in mind, if they're the S, we must be the C for client. Clients always connect to servers with what two pieces of information have we already gone over? An IP address and a port. A port number. Right? So this is how it works. This is direct connection. This is ancient as absolute shit. It is still used today, believe it or not. It is actually still used today in certain situations. Direct connection is always, a very good thing. But in the case of security today, we have a lot more security measures to get around and bypass, etc., etc. Now, let me take this a little bit deeper. So we have this diagram. You guys should easily be able to understand this, that you create the virus, you send it out on the web, the victim would download it, run it, execute it, they would start listening on a port. So if that port was 33, just for shits and gigs, right, then we would have to connect on port 33. But we would also have to know their IP address. Now, how the hell are we going to know that? We don't know jack about this person, right? That's because malware writers would get a little bit creative with it. So you guys probably didn't live back in the day. I guess I'm getting older. Shit. But back in the day, we had ICQ notifications. And we also had, of course, email and all that good stuff. So in order to get the person's email, or the person's IP address, rather, sorry, to be able to connect to, the virus that runs in their computer, on their computer, would actually send us an email to our email client. And we would get that saying, hey, you got a new person, blah, blah, blah. Now, we already know the port number because we programmed it into our virus anyway, because we told it to listen on port 33. But what information we don't have is the person's IP address. So we had to get that emailed to us so that we could type it into this field in the rat. And then we would type 33 in this field in the rat. And then we would click the connect button in the rat. Then it would connect to them. Just like that, right? It would connect through the internet, through to their IP, and we would get them. So this is direct connection. Okay, guys? Old as absolute hell. Ancient as shit. Still used in some situations. And can still be used in situations, even today, in the malware IT security research community. But very old, very crappy. So I want you to take a look at some direct connection-based Trojans, or rats, right? So let's take a look at the first one, which is sub 7. Now you remember how I told you have to type in their IP, and then the port, and then connect. This button over here is to check connection or ping. So what you would do is you would enter in their IP, enter in their port, and then connect to them. And once you were properly, once you established a valid TCP connection to this person, you would essentially be able to rat and do whatever you'd like to them. You got the IP scanner. You can go into keys, advanced, fun manager, extra fun. You can do all kinds of crazy crap with them. And yeah, like everything a rat does, right? Only this rat is ancient as absolute piss, and no one who uses it today hardly at all. So let's move on to another direct connection rat, just to see another example. This is ProRat, written by, I forget the name of the group, Pro Group or whatever. I guess they were from Turkey, and they wrote this in C++ back in the day. So you would type in the person's IP, the person's port, and then you would connect. Now, the cool thing about this is that ProRat, I believe, actually supported an advanced feature with this R checkbox here. That stands for reverse connection, I do believe. Now, that's what we're going to talk about next, but we're not there yet. So let's, yeah, actually, we are there. We're totally there. That's pretty much it. This is it, guys. You'd connect with the IP and the port, and you'd be able to get all this stuff like you would on a normal RAT, and you'd be able to control a remote computer with it. Now, let's close these two out, and let's go back to the drawing board. So let me grab my little eraser here. So just remember, direct connection is when the attacker was a client socket, and the client socket, being the attacker, connects to the potential victim, being a server. The server is the victim, right? All right, cool. So let's go ahead and get this all out of the way. Let me just erase all this crap. And there we have it. Okay, great. So now then, essentially, we're going to talk now about RC. So what is RC? RC stands for reverse connection. So let's do the whole globe thing again like we did before. So this is the World Wide Web. And this is going to be the same thing. So this will be the victim, and this will be us. The only problem now is that there's been a new device created in the world, and this is what screwed everybody over in the beginning that was using direct connection based Trojans and rats and stuff like that. And that is this little doodad right here. You can already tell what it's turning out to be, right? It's a wireless router. So when these buggers were invented, basically direct connection stuff got screwed over badly because of NAT, network address translation tables. So let's kazee this out because we're not done here. So now, not only does a person have to have a way to connect to the internet validly through their ISP, they also have usually a wireless box. So you have your modem, and then you would have one of those routers attached to the modem, right? So the same thing would be over here. So this guy would have a modem, and then he would have another little boxy thing, which is his router, and that would be a wireless thing. And it would just emit wireless all throughout his house, right? Really shitty wireless, because back in the days of like ABGN and all that, wireless was trash. But anyway, so basically, this is going to be the attacker, and this is going to be the potential victim. But there's other stuff in the home. There's like a laptop here, you know, with buttons on there or whatever. It's a terrible looking keyboard, but whatever. So, you know, there's this, there's, you know, your mom's phone, whatever. This guy has a laptop, you know, the attacker dude, he's got a laptop downstairs or whatever. And they're all connected via wireless in their home. This is where a lot more routing takes place. And it's the router's job to, you know, network everything out with DHCP and give everything an internal LAN IP address. So you might have, like, for example, we'll put this guy here. Here, we'll put the default gateway. The router itself could be, here, let me Control-Z that. The router itself could be running at 192.168.1.1, for example. But this guy up here, he might have 192.168.1. You know, 120 or something like that. And then this guy might be on something else, 192.168.1.178 or something like that, right? And then the cell phone down here might even be on something even different. So it might be 192.168.1.56, something like that, right? So then on our end, let's just give our end here as well. Let's say that ours has the same internal local area network, you know, subbing and whatnot. So let's do 192.168.1.1. So it's the same thing on our end, basically. We've got the same local subnet, and we're going to do an internal IP for this one down here at 192.168.1.2, and this one up here, which is going to be our actual attacker. We'll put him at 192.168.1.56. I don't know, just something stupid. Just make it up, right? So essentially, now, in order to properly do this, we would have to, here, let me show you this. If we tried to do direct connection, like if we tried to use Sub7 rat or any other rats that were designed and coded to be direct connection now, here's what would happen. We would become the client and they would become the server. Just for a second, okay guys, just bear with me. If we try to type in their IP and connect to them, and it has to be their global IP, by the way. So we try to connect through our router, through the internet. It's working so far, guys. It's working. We're almost there. We get to their modem. Maybe we make it through their modem even. But when we get to the router, ding, packet dropped. We're fucked. You see what I mean? This is because they are not port forwarded to be able to accept that socket data from that port number we tried to connect in on. There's a tunnel here created with port forwarding. It doesn't work. It's just not going to work. So like, we're screwed. So I'm going to Z that out and we're going to talk real talk, okay? So nowadays, to bypass the wireless routers, by default, most wireless router companies in the world, if not all of them, by the way, allow traffic to go outbound, but not inbound by default. So what that means is we create the virus on our end, right? So this is going to be our virus right here. And it's going to be, here, let's do, I wonder if there's like a thing where I can do, I guess you can't change the radius of this damn thing. Oh, well. All right, so we'll be the S, okay? So we are a server socket now. So we're an S, okay? And we create the virus, we send it to them. Somehow we get it to the internet on a website, or we send it to them, right? Okay, so this is how an attacker would work, right? So somehow we get it onto them, all right? We get our thing to them, they want it, blah, blah, blah. And they execute the thing that we gave them, and it becomes a client. And this client already has our IP address and port number pre-programmed into itself. So it already knows to connect to our global IP at our home, right? Now, think about it like this. As the attacker, we don't have control of the victim's router. We don't. We can't access it, right? Unless you go driving around war driving with a Pringles tube and, you know, I'm just kidding, guys. You hack their Wi-Fi and then type in their internal and get in there yourself. But no, that's likely not going to happen, especially if you live in the United States and someone else lives in, I don't know, fucking England or some shit. You're not going to take a plane, go over there just to do that, right? So essentially what would happen is the client knows your IP and it knows your port number too. So it connects through their router, bypassing the NAT tables and getting out to the internet and all this and that, right? Goes through the internet, gets to your stuff, gets to your router, but ding, it loses it. Oh shit, that's because we forgot a step. Because guys, you got to remember, you got to port forward. So let's say the port number is going to be 33, just for pretend. So that means this person has to connect on port 33 to your global IP address. And let's just say your global IP is, you know, I don't know, 125.36.56.4, whatever. Just that's going to be your, that right there is going to be, oh shit, I did not mean to do that, guys. This is going to be your IP address, okay? Just for pretend. So it takes this information and it puts it to the socket, and it makes a connection through the internet, through its router, through their modem, through the internet, through your modem to your router, and then you would have had to have opened up your web browser and gone to your default gateway, which is your router, and set up port forwarding on port 33. You would tell your router, this thing right here, the Wi-Fi router, you would have to tell it, hey, look, I want you to send any and all traffic coming through from port 33 externally to my internal IP address of 192.168.1.56, which is the attacker's computer where the rat is actually currently running on. So then what would happen is they would connect, they would come through their stuff, through the internet, through your stuff, to your router, and your router would go, oh, hey, this is port, someone's trying to connect from some weird IP across the world, and they're on port 33, so here you go. And it forwards all the data on port 33 to your PC here, right? You follow me, guys? Then the person shows up on the rat. See, it's that simple. So now you know about port forwarding and you know about direct connection versus reverse connection. In direct connection, you act as the client and the victim acts as the server. But in reverse connection, a more modern day approach, the victim acts as the client and you act as the server. So it's reversed. You get it? So now, and this is actually a better method because you have more fine-tuned control over stuff. You don't have to take all of the other steps to get someone to connect to you because you should already know your external IP address. You can just Google it, right, from an external source. And the port number, you can make whatever you want. It doesn't have to be 33. It can be 1111. It can be 2222, 5828, 4857. It doesn't matter. Anything you want. I can even make it 3333. So then you would want to make it 3333 everywhere. Right? So once they make an established connection to you, you'll have them on your screen and you'll be able to, remotely control another computer across the internet. It's great. So guys, I hope you learned from this. These are the main two lessons that I have to get across to you about sockets. So I hope you paid very close attention to me writing the S's and the C's because, again, here, let me go ahead and erase this out. Basically, we're going to go over this one more time. I'm sorry, I just got to be extremely thorough with you guys. God, I wish there was a way to like erase everything on here without having to go through it like this. But anyway, so let's take a look at this. So remember, there's two different things. I probably should have done this first. This is a client. This is a server. And I'll even put them in little squares because kind of like we do in Delphi when you drag and drop their non-visual components. So they look like this, little squares, right, with little icons on them. So basically, a client has to connect always to a server, not the other way around. No. However, servers can be made to somehow do this, but we're not going that deep. All right. We're sticking very, very simply. And just so you know, some of the professionals looking at this might say that's not possible. But yeah, it is. You make them spawn a C. Just don't fuck with me. All right. So, so the thing is, the clients always connect to servers, and they require two pieces of information. Those two pieces of information are an IP address and a port number. So that's it, guys. It's literally that simple. And the server's job is to wait and listen. Here, let me Control Z that. It's to listen on a port number. Let's say 33. So that means that this guy has to connect on 33 to the IP address of this server. Okay? So on port 33, let's say that you make a valid connection. Okay, let's say that a client makes a valid connection to the server. In the server's memory, we'll just make a long little list here. This is kind of like a stack. You can think of it as like a stack, a software stack or something, right? So it's inside of this, if you have another client down here, and you have another client right here, and say you got another client right here, and this guy connects to the server, and this guy connects to the server, and this guy connects to the server, then you're going to have placeholders up here in memory for each one of these. So there's 1, 2, 3, 4. 1, 2, 3, 4. So now you can see that the first guy to connect is person number 0. The next guy is number 1. So here, I'll actually see if I can just do like this. It'd be like 1, 2, and 3. Computers count from 0. So person number 1 would be a socket index of 0, then 1, 2, 3. Now this is in no way absolute. Everything has a socket handle. So this is a little bit more kind of out there, but all of these have what are called socket handles. Okay, so each one of these so-called people, right, that are connected, these client sockets that are connected in, they have socket handles. Socket handles are basically just usually words like just like a number, I guess you could say. It's like a handle on that specific socket connection, but you can index them by numbers. So like 0, 1, 2, 3 in Delphi. A lot of the work behind this type of stuff is really encapsulated away from you so you don't have to work with it. Having to work with it, trust me, it's a bitch. I've actually had to work with raw sockets before. It's a pain right in the ass. But we're not going that deep. We're just going with basic components like these, like I've showed you already. So in terms of these, everything has its own socket handle, everything has its own connection stuff, and it's all handled under the hood by the developers of these socket components. So you don't have to truly know 100% of everything to be able to get started and work professionally with sockets, because most of the hard labor has already been written under the hood for you, so you don't have to do it, right? Oh, and by the way, I should also admit as well, just about every single one of these is asynchronous in a way. So like you can handle multiple connections with all of these sockets by default without having to program even a single line of code. How awesome is that? Really cool. That's why I love Delphi. So basically, this is it. So now you understand clients connect to servers, not the other way around. Clients connect with two pieces of information, an IP address and a port number. Servers wait and listen for connections on a port number, and then they store those connections in valid memory space and hold on to the handle of the socket, so that way you can loop through them and you can make both the client send data to the server, and the server can also send data back to each individual different client if you choose to, which is really, really cool. So you can have a communication platform talking back and forth. So if the server happens to be, you know, your rat or whatever, then he's going to be able to talk and receive from everybody. Every single client can be communicated with. Really cool, right? So that's that, guys. Let's go ahead and minimize this down and pull open this. So now that we have a basic understanding of sockets and the way they connect and whatnot, it's time to perhaps attempt a little bit of practice with them, okay? Now, I do have a lot of other videos covering a lot of different socket libraries in Delphi, and I am going to leave every single link that I have of every single other video that I've ever made on my channel with sockets in Delphi and network programming. I'm going to link every single one of them in the description of this video. So make sure that you scroll down, click on each one, watch them until you find a library that you would like to use. Now, for this whole course, I can tell you right here and now, the only two sockets that you're ever going to need are going to be the NC client source and the NC server source. Now, you guys don't have them installed just yet, so just don't freak out. We're going to go over that in just a moment, okay? So just bear with me a little bit, because we're going to go over how to install these, okay? They're really simple to deal with. We're also going to go over how to install these, because we're going to be practicing with these just a little bit today, okay? Just to get the kind of basics down of everything, okay? So I'm going to go ahead and we're going to close out of this, or better yet, we're going to just delete everything out, and we are going to do some practicing with this stuff. So I'm going to have to open up another project here, so you're just going to kind of have to bear with me a minute, guys. I'm going to open up a separate Delphi here, and I'm going to make another Windows VCL form application. We're going to do some programming. We're going to do programming with the clients and the servers. So we're going to design a server, make people or clients connect in, and then we're going to see if we can get them talking. Okay, this is going to be really fun. You guys are going to love this. So again, we're not working directly with our rat project, so don't worry about opening that up. Just bear with me. I will guide you through every single step that is required to get this stuff up and running and done, okay? So just bear with me and pay attention. Okay, guys, so here, let me, I'm trying to think of the easiest way to do this. I'll tell you what, let's just work with one form. It'll make the video much simpler to do. That way I don't have to use two Delphis and actually program this. I'll try to separate everything out where you can really see it. So let's just make two group boxes just real quick like I did before. Probably should have just left it on there. So this will be group box 1 and 2, and we will have, let's put this up there. This will be client, and this will be server. So, okay, guys, look, you have to pretend, okay? You have to pretend that this is actually two different programs, okay? Even though it's running as one, okay? So don't be confused. So it would be like me writing the client here and making a new Delphi open, and this would be like the server or something, right? So you have to understand that. So don't be confused. Just pretend you have two Delphis open and you're coding them separately, okay? So they can run on different computers. But I don't have another computer to really play with right now except one of my main servers, and I'm not willing to open that up. So we're just going to have to work with this, okay, for now. So what I'll do is in this, we're going to grab ourselves a server. So on the Internet tab, I'm going to grab a server socket just like this, okay? Just a simple T server socket component, okay? Now, you guys don't have this yet, so okay, I'm going to go over this with you right now before I add it. Let's do this, okay? You don't have these, so if you look on your Internet tab, see this Internet tab right here? You guys will not have these two things on here. There's T client socket and T server socket. So let's get that installed right now, okay? All you have to do is go component, install packages, and whenever the form pops up right here like this, what you're going to do, you'll see a little window kind of like this one. Mine's big, but yours will be really small. But you're going to look at the bottom. There's a button that says add. Okay, so click on that. Then you have to go to C, Program Files x86, Embarcadero, Studio 23, or whichever version you're using of RAD Studio. In my case, I'm on 12.2, I do believe. And then we have to go to the bin folder, which also stands for binary, I believe. So you go into bin, not bin 64, just bin. No need to go into bin 64, okay? Go into bin. And when you're here, you're going to have to scroll down and either find it. Now, I'm too lazy to go look for this crap, guys, so I'm not going to do it. I'm going to type DCL sock. So once you type the word DCL sock, you'll see DCL sockets 290.bpl. This is the package you need to have typed in here. Okay? Then you click on open, and it's going to install them automatically in less than 2 seconds. You're like, okay, I'm not going to click it because I already got them, but I can assure you that once you click open, and I'm going to show you. So pretend I clicked open, okay? Now you're going to look in here, and you will see, let's see what I can find. You will see this. So you see how this is DCL sockets 290.bpl? This is a BPL package. So basically it should have a checkbox on it that's checked. That means they're installed. Okay, guys? And that's all you have to do. Now you have to click save right here at the bottom right. Okay? Now I'm not going to save anything because I didn't do anything. I'm just going to hit cancel. But you guys hit save. Okay? Now you can find both the client and the server inside of the Internet tab. Okay? And by the way, one other thing. If you add these, like if you try to add these like in that window that you have open when you clicked, when you typed in DCL sockets and all that, if it throws an error or something, close the IDE, reopen the IDE and try again. So you'll go component, install packages, then you'll click add, then you'll browse to C drive, and you'll go Program Files x86, Embarcadero, Studio 23 bin, and then you'll type in DCL sock, and you'll go 290 DPL, and you'll try to add that again, and it should work, okay? Eventually, you'll get to the point where it does work. Usually, you won't have a problem, though. So, all right, so now that's all over with. We have the client side and the server side, okay? So what we're going to do is we're going to practice a little bit here, guys, okay? We're just going to have a fun little game of practice. So we're going to grab a button. So this is going to be called, this button, we'll just leave the name as button 1, and then we'll change the caption of it to connect. And what we have to do, remember, clients require what? 2 pieces of information, right? In order to be able to connect to a server. They require an IP address and a port. So let's grab an edit box. Throw it down, right-click it, clear it. Now, let's go ahead and grab a spin edit. So I'm going to grab a spin edit, and I'm going to make the minimum value of 1, the maximum 65535. I think that's the max number of ports. I can never really remember that. But anyway, let's go back to the value property at the bottom here and make this 3434. So now we have the ability to type into this edit field an IP address, and then we have the port number placed into this, which we can we could do like this if you really wanted to. And if you want, you can also add a label. And we're just designing, guys. This is really basic stuff. So like all we have to do is just drag this up a little bit here. And we can say, this could say like port. And now, you can put that wherever you like. I'm just going to leave it as is. And then you can drag this, make it look nice and tidy if you'd like. Drag it on up. And then we're ready to start programming. So whenever we click this connect button, what do we want to happen? Well, I'll make it easy for you guys. Like seriously. I'll grab another button. This is not necessary at all. And as an advanced developer that's been doing this for over 20 some odd years, I would not do this personally. I just keep everything on one button click and do an if then else statement or something like that. But we'll do it super simple. I'm having to pretend that you guys are total beginners, okay? So we're going to keep it all visual and keep it all event-based and super simple to follow, okay? So this will be connect and disconnect, okay? So when we run the program here, let's select the position of this form, and we want that to be the screen center. So position, position, screen center, okay? So when I run the program, which I'm going to do right now, it'll pop up right here in the center of my screen. So to you guys, it's a little bit to the right because I'm recording different parts of my screen, but it's like kind of like here what it should have been like for you guys to see on my screen. So we can try to type in 127.0.0.1 and then the port numbers here, and we can try to connect or disconnect. You see that? So if we're not connected to begin with, the disconnect button does not need to be enabled. So let's go ahead and find the enabled property of the disconnect button, which is button 2, and disable it. Now, when we run the program, you'll see that you can only connect. You can't disconnect because you're not even connected in the first place, right? So let's go ahead and do the programming code part of the connect button, which is super, super basic. So we're going to type in self.clientsocket1.host is equivalent to something. And this actually needs to be self.edit1.text because it's just the IP that's in here. So giving the client socket an IP address from the edit box the user typed into. So that's that. And then the port, self.clientsocket1.port is equal to, let's say, self.spinedit1.value. That's it. Giving the client socket a port from the user's spin edit control. And that's it. So now we can type self.clientsocket1.open. That's it. It's going to attempt a connection. That's it. So you set the host, the port, connect. Boom. So I'll put a comment here, make it connect. Yay! Okay, great. So there you have it. So now there's just one problem, and that is that we haven't made the server yet. So if you try to connect right now, here I'll show you. If you try to connect with localhost typed in and hit connect, it's going to give you an error because there's nothing to find. It's a 10061 error, meaning there's no server found. Server was not located, so the host was not found. So what we have to do is tell the server to listen. So let's go ahead and grab an edit box, or actually, I'm sorry, a spin edit. So let's grab another little spin edit here, and let's, here, I'll tell you what, I'm lazy. Let's just copy this one. Here, I'll tell you what, let's copy both of these. I'm lazy. There you go. There's your port, and then we'll grab ourselves a button. So let's grab a button, throw it down, and here we'll put listen, right? So in this button code for the server, we're going to go into the button code by double clicking. This is the button click event procedure. We're going to type in self.serversocket.port is equivalent to self.spinEdit2.value. Then self.serversocket1.open. Done. Problem solved. Now it'll be listening. And once it does listen, we can say self.spinEdit2.enabled is false. Self.button2, or rather button3.enabled is equal to false. Self.button3.caption equals listening. So now when the user clicks the button, the server will listen on whatever port they typed in here. The button will disable itself and change the caption of itself to listening. So that's that, right? So here, let me show you just real quick what this will look like. So yeah, let's do this. So I'll show you this. We're going to program some more stuff because we're not really done yet, but we do have enough to make it actively try to connect. Nothing will show if we're successful, but I'm going to listen on port 3434. And as you can clearly see, we are currently listening on that port. Now I'm going to try typing localhost, and I'm going to try to connect. I'm connected successfully because we didn't get an error. However, that doesn't really help us that much since there's not really anything to show us that we actually are connected, and the user can keep clicking the connect button, which is not a good thing. So what we're going to do, I'm going to talk to you about socket events. So every socket component, or rather every component rather, in the entirety of this language, when you click on them, you can see that there's the object inspector. You have properties, which are what make the thing look like what it looks like what shape it is, what captions on there, what color it is, blah, 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 blah. But also you have events for event-driven programming. So, for example, the sockets have their own properties and their own events. Now, socket properties are not going to make it look like what it looks like because sockets are non-visual components, see? We can hide them by clicking this button up here. In other words, when you run the program, you don't see them because they're invisible. They're nothing more than code running in the background, okay? So whenever we run this, we want to have some events set up here to show us just what the hell's going on, right? So let's grab ourselves a memo so we can at least have something to look at in the meantime for whenever these things actually do connect. And I'm going to go to the lines property here and get rid of that. Then on this end of it, I'm actually going to make a list view, and I'm going to set up some columns. I'll just do one column. Actually, I'll do two. I'll do true on both of these for auto size, and the first column is going to be IP address, and the second column is going to be port. And then I'm going to make this a view style of report. So there you have it. Now you have the ability to see who's connected on the actual server side. So let's go ahead and do this. So whenever we make an established connection from the client side, we want the client event. So there's different events for the client and there's different events for the server. On the client, we have on connect, on the process of connecting, on disconnect, if there's an error, on lookup, on read, and on write. On the server, you have on accept, so when a socket is actually accepted as a connection. You have client connect, so whenever a client connects, something can happen. When a client disconnects, something can happen. If there's an error with a client reading, client writing to, on get socket, on get thread, listen, on thread end and thread start for multi-threading each different socket connection. So a lot of stuff to take in, I know, but the funny part is the only ones you'll really ever use are generally going to be, here I'll show you, on connect, on disconnect, on read, and that's pretty much it. So so that we don't have any errors, I am going to suppress errors. So I'm going to go into the onError event procedure of this client socket here, and I'm going to say error code is equal to 0. I don't want to show errors. Do not show errors at all. So we're just suppressing errors. That way I don't have to deal with crap. So we can just leave this one. This one's fine. So whenever the client actually does connect, we want something to happen. We want it to tell the user, hey, you did make a successful connection to that server. So on connect, we'll put self.memo1.lines.add, and then we're going to put a message in there. We're going to say successfully connected to, and then we'll put this as socket.remote host, or remote address rather. Now, if you guys are wondering how the hell did I pull an IP address from this, guys, these events, so like, let me show you this client socket right here. When you click on connect and go to the code, or on connecting, or on disconnect, or an error, lookup, read, write, sometimes when you go into these, they give you parameters to use. So sender is a T object, and then socket is the T custom win socket, which is currently responsible for this exact connection. Very cool stuff, right? So in other words, in order to get the server's address that we actually connected to, all I had to do was tap into the socket object here and tell it, get me the remote address that we're connected to. That's it. It's that simple. Okay? So I think you guys pretty much understand that at this point. Very simple stuff. And it's one line of code. Nothing complicated whatsoever. On the server side, I want to make it do something similar. So when a client connects, I want to see that person show up in the list view. Okay? So let's see if we can get that part done. So on a client connect, we're going to make a variable called li, which is a list item, t-list item. And then we're going to say li colon equals self.listview1.items.add. And then li.caption colon equals socket.remote address, and li.subitems.add, and then self.serversocket1.port, which is an integer. Now, this is not going to work because an integer is a number, not a string, right? So you see how this is saying incompatible type string and integer. So in other words, we can't just add the port directly because it's an integer, and the subitems inside of this component are supposed to be strings, okay? So what we'll do is typecast. We're going to do what's called typecasting. We're going to typecast from an int to a string. And that's it. Done. Problem solved. Okay, so let's get this done. Let's see if this actually works out. If I'm correct, hopefully it will. So we're going to listen on port 3434. We're going to type in 127.0.0.1, and we're going to make a valid socket connection by clicking connect. And as you can clearly see, we have actually connected successfully to our server. And the server, likewise, notices that we are a connection on the server's list. Great, this is fantastic, guys. So whenever we do connect, on the event of connect on the client socket, let's set this button to disable itself and this button to enable itself. So on the connect, we've got the successfully connected to this blah 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 self.button1.enabled colon equals false. Self.button2.enabled colon equals true. Now on the disconnect button, we need to tell the socket to disconnect. So self.clientsocket.disconnect. Actually, it's close. So that's it. Disconnect from the server. It's that simple. Okay? So now, once we do this, we want to take these buttons and re-enable them. So you see how we did these two right here on the connect? We'll copy those, paste those, and reverse these. Just like that. Okay? And we never did disable the spin edit or the edit, but I really don't care. It's fine. It'll be great. So on the list view, let's make this show a little better with read only and row select both checked. So now, whenever someone connects in, it should function a little better now, just a little bit better graphical wise. Here, I'll tell you what, guys, since we're going to be typing this in a lot, let's just make the text local host, and then we can continue practicing. So, okay, for this, we've got listen, and we've got connect. And as you can clearly see, oh, whoa, I've got a bunch of stuff coming in on that port. Hang on, guys. Let me change this up a little bit. How about instead of that open port that I've got, let's go with, let's just go 3435. And we'll do the same for this one. 3435. Totally forgot I had that port in use. That's for some other stuff I've got running on my server. Okay, so localhost on 3435. Let's listen and connect. So now we have a valid connection on this port, 3435. And if I want, I can try to disconnect. However, you guys are going to notice something. This does not disappear. Watch. Okay, now why didn't it disappear? The thing about it is that we didn't program the server to remove the client connection from our valid connections in the list view. So how does that exactly work? Well, I'll show you. See, if I connect again, it'll just add another one, you see? And disconnect, reconnect, disconnect, reconnect, disconnect. But really, all of these are not even on here at all. So what we got to do is, on the server has an event called onClientDisconnect, right? So if we were to go in here, we can program what we would like for it to do. So I'll make this list item. And we could do this several different ways, but I'm going to say for li in, and I'll just erase all of this, in self.listview1.items do. We're going to do a for loop, which is for each list item inside of the list view items. We're going to loop through if li.caption is equivalent to the socket.remote remote address, then we are going to begin and we are going to say li.delete. So this should be a simple loop to simply delete the person based on their remote address, which, by the way, is a terrible idea, but we'll get into that later in some of the deeper content in this series, okay? But for now, this is going to be as simple as it gets because you guys are just starting out, right? So, and what I mean by all that is it's not a good idea, guys, to view and monitor people like clients that are connected via their IP address, because think about it. What if you have 10,000 client connections from the same computer, which might be pretty freaking fucking ridiculous, but you get my point. If it's going to be the same IP every single damn time, this loop would be absolutely pathetic, because it would delete every single one of the things from that same remote address, even if the socket connection were still connected like through other ones. It's ridiculously crap. But for now, we're going to stick with this because it's super basic, super simple. You guys get the point. We're just practicing. So when I open this up and I listen on that port and connect, you can see that the person is connected and they know they're connected as well, and you know they're connected as well. So if I disconnect the client from the server, boom, they go away. See? Very cool stuff, right? Right? So there you have it. This is very, very super basic socket connectivity based stuff. So I'll tell you what, I'm going to pull this up and I'm going to pull this up and we're going to practice even more. We're going to make a chat program. So let's go ahead and put a button down here and we're going to call this button caption of send MSG. Okay? And then we're going to take that button and we're going to paste it over here, same way we did before. And we're going to grab ourselves an edit box. We're going to need 2 of these. So I'm going to clear that out and I'm going to put it right next to the button. I'm going to copy that, paste it here, and do the same damn thing I did there here. Except I am going to try to make these as long as they need to be. And I'm going to try to make this one longer as well. I'll tell you what, I'll try to even them up with these. That way it's not so bad. I'm pretty picky. All right, so then we'll have ourselves a, let's just grab a memo, okay? So this is going to be a memo. And we're going to put this memo right here for chatting back and forth, okay? So I'm going to go to the lines property of this. And I'm going to get rid of the memo2, copy that, paste it over here, and we're going to just kind of make this a little bit bigger so it's a match, okay? So, guys, this is pretty cool so far. So, what we'll do is the client user will be able to type something here, click the send button, and that message will be sent to the server. The server will receive the message and throw it in the chat queue, the chat view here, which is going to be our memo 3. So let me double click this button to go to the code. So again, we're saying self.clientsocket.socket.send text, and we're sending a message. So self.edit, and I believe it's edit2.text, and we're going to say client says, and that, okay? It's going to be that basic and that simple, guys. So now, let's make sure that this is actually edit2, and it is. Fantastic. But before we do that, we want to make sure that we not only send the text, but we also want to say self.memo2.lines.add you said, and then plus self.edit2.text. Then we want to say self.edit2.text, or .clear rather, self.edit2. Actually, I was going to set focus to it, but I'm not going to. We're just going to leave it as that, okay? So here's what we're doing. We're sending the message of text over the socket connection to the server first. Then we're adding lines saying, hey, you just said the following to the server, right? And then we're going to clear out the edit box, and that's it. So now we're going to do the same exact thing on the server, but the server's handled just a little bit differently because you got multiple connections you got to loop through. So it's really simple. I'll show you guys right now. And if you guys remember my little speech earlier on socket connections, you'll remember that everything has an index. So these components make it super, super simple about index stuff. So let's go to the send message button on this side and say self.serversocket.socket.connections, connection number 0.send text, and then we're going to send server says plus, and then self.edit3.text. Then we're going to say self.memo3.lines.add you said plus edit3.text. Then we're going to come on down and say edit3.text, actually edit3.clear, just like that, okay? So now then, we have a program that you can use to talk back and forth to each other. Cool, right? So let's get it connected up and see what happens, shall we? So I'm now running the program. I'm going to listen and connect. Now I'm going to start talking to the person on the other end. So, hey, server, what's up, bro? And then I'm going to click the button. Okay, so we said to the server, hey, server, what's up, bro, right? But they didn't get it. It's because we didn't program it yet. Now watch this. If I type in, hey, man, and I hit send message, it says, hey, man. So now let's program it in where they receive the command or receive the text and throw it on these memos. Super basic to do. All you have to do is click on the socket that you're trying to mess with, go to events, on read. And on the server, it's called on client read. So on the client, it's called on read, but on the server, it's called on client read. So let's do this right here on read. For the client, let's say self.memo2.lines.add socket.receive text. That's it. Just like right here, because we have direct access to the underlying socket object, the T-custom WinSocket responsible for this socket connection. So I just say, memo2, you're going to add whatever text is received by this socket. Done. Problem solved. Okay, so now we're going to go to the server, and we're going to go on client read, and we're going to say self.memo3.lines.add, and we're just going to put socket.receive text. And that's it. We're done. So now we can run the program and see if we can talk back and forth fully now. So I'll say, hey, server, what's up? And then I'll hit send message. Or, well, we got to connect first, guys. Don't want to forget that. Let's try this again. So let's copy that and send it. And as you can see, we receive. So then I will simply say, hey man, not much, just deving in Delphi, and send it over to this. So now you've got both sides talking. Pretty cool, right? So you can disconnect, and then you can connect back in. One thing you might want to do is whenever people you might want to disable all the functionality until the sockets actually get connected. But in any case, this is it, guys. And I'll show you one more time, a little better example. So you're connected, blah, blah, blah. I can type in a bunch of random stuff and send it. And that's what the client just said to the server. And then I can type a bunch of stuff back, and then the server says this, you see? So there you have it. Now, this is the most basic stuff in the world to deal with, because, guys, what you've essentially done here is this could be made into a rat. Like, I shit you not. Like, here, check this out. Like, you see how, like, on the client right here, how they receive the message and they throw it in there, right? So, like, on read, where we do this single line of code here, you could actually create the ability to send secret messages that are actually commands, like, with stuff to do. Like here, for example, here, I'll do like this. Let's do variable data, or I'll put yeah, data, and then I'll do data is received text. So now this can just simply be data, but I'll say if data dot contains secret command, then begin show message. Oh my God, you're hacked. Else we can begin doing something different. So now, if I run this, okay. So we're gonna listen and connect. So now, if the server sends like, "Hey man," you know, and then they get it. They get, "Hey man," you can talk with them. You know, you can be like, "Yo yo, what's up?" You know, and you can talk back and forth. But if the server wants to secretly do something to the client, which may or may not be, you know, so legal, so to speak, they could simply type in secret command, and then they could send it over, and whatever was programmed into that secret command on the client could take place on that person's computer. See, watch. See, it says, "Oh my God, you're hacked," you see? And this would happen on the client, like so over here. Not the server, but the client, right? You follow me, guys? So if I click OK on that, notice how it didn't show anything in here. Like before we typed, you know, "Hey man," and "Yo yo, what's up?" But that secret command thing never showed up in here. That's because we didn't tell it to, because it's a secret command. We didn't want it shown, right? Pretty crazy stuff, right? So just think about this. What if you had over 5,000 plus commands to issue, and you could take over, you know, a computer, you could grep passwords out, decrypt them. I mean, guys, this is literally the key to the world, so to speak. Sockets are the key to the world. If you're able to program with sockets, you have a very powerful skill. And if you understand them, and if you understand them at extremely low levels, you'll be even more powerful. So in any case, this has been a lot of fun just sitting here, like going back and forth with you guys on this. This is fantastic. So easy, simple as pie, simple as piss. I mean, literally, Delphi makes this so easy. Most of this code, I didn't even have to write. Delphi literally takes care of you almost nearly 100% of the way. The only code that I've written are these 3 lines, these 3 lines, these 4-5 lines, these 3 lines, this, 1 line, and my little loop that runs through, or my, you know, my little detection thing for my secret thing, and that's about it, guys. I mean, this stuff is so basic, it'll blow you away. And if you were to cut this in half, think about it. One of these is the client, one of them is the server. There's a total of 160 lines in this application total. Only half of that would be there had we split this up. So literally, it's almost like saying that really the only lines you write up literally, it's probably like 12 to 20 lines of code literally, and that's it for both client and server, which is nothing, like literally nothing. And the thing about it is that if you use different socket components available on this component palette up here, you can actually make this same program run on every single operating system on planet Earth with just a simple click of your mouse. I mean, this is absolutely fucking insane, guys. So, all right, so this essentially this has been just a very brief, basic overview as to how to get started with sockets. So, I think I'm going to go ahead and show you guys one more socket library just to kind of help get things on the roll here. So this has been the T client socket and the T server socket components that are natively available in every version of Delphi since version 6 or 5, 6, and 7 that I'm aware of. And you can use these in any way that you see fit. You can also make them send audio and video data. Just convert whatever you're sending to bytes and send it. You can also do, well, pretty much anything. Just convert anything and everything you want over to bytes and send it. A lot of that stuff can be a little bit more advanced because you do have to tell these specific sockets how much data to expect to receive because they don't have built-in functionality for that. So if you're trying to send a file from the client to the server or from the server to the client, I have an example of this on my GitHub page. So I can, I'll link that probably in the description of this video as well so you guys can go take a look. But it is for more tech savvy people who know what they're doing with sockets. So you might take a look, you might not. If not, it's fine. Just guys, you don't have to be, this isn't crazy stuff, okay? It's not some crazed mathematical scientific crap, okay? Just stick with the basics for now. That's my advice to you. But we can build on top of this whatever we wish to, and we will later whenever we start diving into how we're going to do this for our rat project, okay? So let me go ahead and I'm not going to save this project, okay, guys? I'm not doing it. This project was just for fun, so I'm not going to give you the code. If you need to look at this, you're going to need to watch the video and recreate it yourself, okay? Now, I'm sorry about that, but to do this, I could do this literally in my sleep, like without hardly even opening my eyeballs. So you should be able to eventually get to this point as well, where you drag and drop a client and a server down. You simply tell the client to connect to the server, and you use the events on client connect, disconnect, and read. Those are the only 3 things you need to play with. This whole thing is just basically garbage. I mean, this is nothing more than a training app, right? So we're going to go ahead and try this again, but with a different set of components. So here, I'm going to go to this one since I've already got this open. Let's go to options. And I'm going to apply a theme since we have this open and whatnot. I'll just do, we'll just go with carbon. So that's nice and dark themed. So, okay, so there we have it. Let's do this, a very similar approach, but we're going to use a server from this and a client from this. So this is going to be a client source right here. Okay, so guys, remember how we did this before. So let's do, let's simply do a group box, and we'll throw it down. These sockets are cross-platform, which means that you can use them on nearly every operating system on the planet, just so you guys know. So I'm going to paste this twice, and we're going to pull that over. This is going to be the server side, and this is going to be the client side, just like we did before. Okay, you follow me? So this will be a caption of, let's say, Netcom 7 sockets demo. We'll do chat demo. so we can get them talking back and forth, okay? So whenever we connect in, let's say that we need to make this connect. So let's pull these up here. Let's grab an edit box. We'll throw the edit box down, clear it out, grab ourselves a spin edit, and we'll throw that down. So now we'll do the same thing we did a minute ago. Matter of fact, I'm just going to copy this. I'll tell you what, let's just copy this and paste it over here in this one because I'm lazy. So there we go. There's our port and all that good stuff. Yippee. So there's that. I'll drag this over to make it look a little more pro. And then we have our edit box for our being able to type localhost. I'm going to go ahead and just make the text of that localhost. And then we're going to need a button for our connect, disconnect. I'm actually going to do this one my way. So I would just use one button and call it connect. So on this side, we're going to grab a port. So we need the port thingy here. And then we need another button, which I'm going to use as the listen button. So let's just drag and drop and listen. So on this, we'll say self.server source1.port will be equal to self.spinedit2.value. And that's that. So now that we have the spinedit2 for the port, set the server's port to whatever we typed into this spin edit2 BCL component. Then we're going to simply say self.nc server source1.active is equal to true. So we're going to start listening on port whatever we typed in. So now we need the listen button to disable. So the listen button is actually the one that's here, button 2. So we're going to say self.button2.enabled equals false. Self.button2.caption equals listening. Okay, so that's that. Let's go ahead and go back. Make sure the form starts in the center screen position. So the position should be position screen center. I'm going to click run, and we're going to see what happens whenever I click the listen button. So 3435, listen, and there you have it. It's listening. Okay, great. Server side is practically done. Now we move on to the client. So on the client side, we want to double click the connection button, and I want to say if self.button1.caption is equal to listen, then begin, otherwise do something else. So we have the, it says connect. So let's change this to connect. If it is connect, then we're going to try to make a connection. So try to make a valid connection to the server. Else begin doing something else. So we are going to say, with this, we're going to say, we'll do try. Whoops. Hang on. Sorry about that, guys. I accidentally hit one of my shortcut keys. Let me delete this out. So we are going to say except on E, exception, do begin, whatever. Okay, and that should be fine. So we're going to try to connect the socket. Self.clientsource1.host is equal to self.edit1.text. Self.nc clientsource1.port is equal to self.spinedit1.value. Now we're going to say self.nc clientsource1.active equals true. Okay, so now we're going to put here silently handle any error on connection failure. So we're just going to put a comment there that says we're not going to really do anything here. We're just going to leave it silent, so nothing will happen. No errors of any kind will show. Else begin, we're going to say self.nc client source. Here, let's go. Client source 1 dot active is equal to false. So disconnect from the server. So for this, we'll also say button1.caption : equals disconnect. And that's going to be that. Now we're going to disconnect down here, and we're going to say self.button1.caption will be connect. Okay, so ultimately this should hopefully work out without any issues. Let's go ahead and try to make a connection to the server without the server listening. So let's say connect. And looks like so far everything seems to be okay. So let's try to listen and connect. And there you go. As you can see, it does work. Okay, great. So fantastic. Our code is working perfectly fine, flawless, hell yeah. So now we have the ability to connect the client source socket directly to the server source, so the client connects to the server without issue. Now we need to program our chat, right? So let's grab a memo, the same as we did before. So this will be right here. And we're going to make the lines property of this equal to nothing. And then at the bottom, we're going to grab an edit. So we're going to grab an edit box and clear it out. And we're going to grab ourselves a button. And we're going to throw it down. And there you have it. So that'll be for sending messages. And I'm going to take every single one of these, copy and paste right here exactly, so they'll be exactly the same. Fantastic. Okay, so guys, at this point, it's just a simple matter of getting the server to send messages from the server to the client and getting the client to likewise send messages from itself over to the server. Okay, so these specific components have a very special event inside of themselves called handle command. This is absolutely amazing. I love this so much. So let's also use the onConnected and disconnected events. So for the client, let's do self.memo1.lines.add connected to server. And let's also take this line of code and let's do this as well. So let's go to this on disconnect. So when the client connects, we'll say we connected successfully to the server. And then whenever the client disconnects, we're going to say that same thing, but we're going to change the wording and put disconnected. Disconnected from server. Okay. So now we have handle command, and that should be it. So on the client portion where we're going to do this, we're going to simply put, to send a message, we're going to say self.nc client source1.exec command. Okay, so we're going to try and send this right here over to the server. So we're going to execute command, and then we have to have a command as an integer. So we're going to just simply put 0, and then we will put bytes of, we'll just put, how about we just put edit1 or edit2.text. Then we have to figure out what else we're going to do. And I think it's, I forget how to actually run this. And if you forget commands, guys, make sure that you just type out what you're looking for. So like you can copy this and paste it above and then open parentheses. And it shows you some stuff that you can use here. So like, as you can see, first is the command, which is an integer. We don't care about the command. I'm leaving it at 0. We're going to send some data as bytes across the stream, and then it requires results. So we're going to just do false, false, and I believe that should be about it. So for here, false, false, and that should be it if I'm correct. Probably wrong, but that's fine. Nope, I'm actually correct. So as you can clearly see, we're just sending this message that we did over to the server. So I'm just going to simply put client says plus edit2.text. The bytes of command statement converts all of this string into like just a thing of bytes to send over the socket. The execute command automatically sends whatever you put in there over the socket. So we're done in one line of code. How cool is that? All right, so now that we've done that, we want to say self.memo1.lines.add you said plus and then edit2.text. Now we want edit2.clear. Done. So the client is completely finished. We have just successfully written the client. So now let's go back over to the server. On the server, now remember guys, on the client we put execute command, which means on the server side we have to handle that command, okay? So this event is for handling commands sent using the execute command structure, way of sending. So on this server we'll do handle command. And on this, we're simply going to receive the shit, right? So the bytes. And as you can clearly see, we have a sender, which is a T object. We have a line, which is the line or socket connection line responsible for this person that's talking to us. We have a command, which is an integer, and constant data, which is a stream of T bytes. Just it's T bytes, right? It requires a result, Boolean, true or false, constant, a sender component, a receiver component as a string, and it receives the bytes that was sent through the socket. So all we really have to do is say self.memo2.lines.add, and we're just going to do a string of a data, and that's literally it. So that right there will put the message received from the person into that, I do believe. So let's give this a quick run just to see what happens. So if I were to listen and then connect and then say hi, the client says hi. It works. It's perfect. You see that, guys? So now all we have to do is make this side communicate with this side. So when we click the button here, this is actually done in a little bit of a different way. So just try and focus up with me here, guys. So basically, when we click this send button, we need to loop our connections and find this guy and send him a message, right? So how we can do that is we can create a couple of variables here in this button. So what I'd like to do is, first of all, we're going to need a list of clients to be able to loop, right? So we're going to need two different variable declarations here. First of all, we're going to need an I, which is an integer type for localized looping. Then we're going to need a clients list, which is going to be a T-socket list, like that. Now, if you guys get an error here, this says that it's an undeclared identifier T-socket list. This is because we have to include the NC socket list unit inside of our Delphi code. So scroll all the way to the top, and you're just going to put a comma after the last uses clause statement thing there, and you're going to put NC socket list, just like that. Okay, now when you scroll back down, you should not see the error anymore because we included the unit with those dependencies in them. Okay, so now we can continue, right? So basically, like I said before, all we're doing, guys, is we're just simply looping through the currently connected people, and we're sending that chat message to that person. Now, in this particular case, we don't have many people connected per se. I could have probably done this with a one-liner, but I did want to show you guys, just for now, how to actually create an object to loop through clients in a simple loop fashion on the server. So what we'll do is say we'll send this to any and all clients that are connected. It'd be like a broadcast message, right? So we can just simply do we'll do clients is going to be equivalent to server.lines, or actually this will be self.nc server source1.lines.locklist. So we're locking up the list of people, which means basically clients, literally as of this line, clients becomes everyone that we have connected to us. Okay, that's all you need to know. Focus on all clients connected to us. Now that we have that, we're going to say, we're going to try something. So we're going to try our best to say for I is equal to 0 to a high of clients.count minus 1. And we're going to do, we're going to say self.nc server source 1 dot execute command clients dot lines I that we're currently looping over that person. We're going to have 0, a data, false, something like this. Now I do believe that the data will be T bytes, so we'll have to convert that to a string. But just bear with me real quick here, guys. So this portion here needs to be fixed. So we want to send the same way that we did above, which is bytes of. So we'll say bytes of server says plus edit 3.text, and that's that. So now we should have the ability to mass loop this out to all of the people that are connected to us. However, let's not forget that we locked the list so that we could loop through everybody really super fast and send to them, correct? Now we have to unlock that list when we're finished with it. So we have to say at the finally portion, we would have to say self.nc server source 1 dot lines dot unlock list, and that's that. Okay, so there you have it. That should be able to send that over to them. And once we are done with this, finally, we unlock the list. We tell it to, once it's unlocked the list, we want to say self.edit3.clear, and that will be that. But also, before we do that, we want to add our message to our own list so we can actually see what we're typing to the person. So we'll put self.edit dot memo to dot lines dot add, and we're going to simply put you said plus, and then we'll do edit 3.text, and that's that. Let's go ahead and give this a quick run and just see where we're at. Okay, so I'm going to listen, I'm going to connect, and then I'm going to type in blah, blah, blah. Here, I'll just type in hello server, and then I'll send it. And the client says hello server. Now I'm going to go down here and say, hey client, and click the send message button. And there you have it. So basically it does send, but we just have to now receive on both sides. So the server is set up to handle a command, but the client is not set up to handle the command yet. So let's go ahead and program that in. Basically, what we'll do is say self.memo2, or memo1 rather, .lines.add, and then string of a data, and we are finished. So now we should be able to talk back and forth. Let's see if it actually functions like we want it to. Listen, connect. Also, as an added thing, we might also want to make the server actually show the person whenever they connect. So on connected, let's go ahead and do that. Self.memo2.lines.add, and we will simply put the client connected from IP, and then we'll do plus a line.peerIP. There you have it. Now we have, and in case you guys are wondering how the hell do I get the IP, it's right here. Just try and really focus, guys, because when you look at these procedures, sometimes they give you shortcuts and cheats you can use, basically, right? So we have sender as a T object, and we have a line, which is in these socket components, it's known as a TNC line. Same thing as the other socket components whenever we looked, and it's known as a T custom win socket in these, but on Netcom 7 sockets, so these sockets right here, it's known as a TNC line. Same damn thing, just written a little differently. And what I did was I typed in a line, which is the current person we're talking to, or should be talking to, that fired the same person that fired this event, and I just grabbed their pure IP address. That's it. It's really super simple, right? So now, whenever we run the program, you'll see that we're able to listen, connect, and as you can see, the client did connect from localhost IP. Now we can type in, hey man, what's up? And then the client, the server gets the command and says, oh, he's talking to me. Okay, yay. I'll say, not much, bro. What's up with you? And as you can see, it works perfectly fine back and forth. So this is how you get sockets to communicate. Now, with this knowledge, you would now be able to make these sockets communicate in a super easy fashion and be able to send messages back and forth and make the both sides do different things. You see, guys, it's like a phone call. It's like a really long phone call in a loop, and you keep on sending messages back and forth, back and forth, back and forth, and doing stuff. It's really crazy how simplified socket programming is in this language. It's so easy, I think my freaking grandmother could do it, and she don't even know what a fucking computer is. So there you have it, right? So I'm not going to save this, by the way, but you guys have this video. You're more than welcome to go over the video over and over and over again. Now, in this video so far, I've established to you different sockets, what they're capable of, and how to set them up, how to program with them. The only thing I really haven't gone over with you, which we're about to go over, is the difference between blocking socket frameworks and non-blocking socket frameworks. So what I've just showed you with both of these projects is in non-blocking mode. So basically what I'm trying to say to you is that I have shown you non-blocking socket frameworks. Both of these are non-blocking socket frameworks, okay? So that is to say the following. So let me go ahead and pull open, let's say, another one of these little Excali draw things, which I had open earlier. So this, we will look for, here, I'm going to give this a little color. Let's give this like a purplish sort of color. Sorry, guys, I got to do that. All right, so on this, let's just grab an eraser. So, and I'm just going to erase a bunch of stuff, blah, 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 blah. And there we have it. Okay, so let's talk about, let's start with blocking, okay? Let's start with blocking sockets. Blocking sockets simplified. So essentially, let's say that you have a program, okay? So I'm just going to make this a simple program. And you have, your little X thing here. You have a little button for chatting with people, a little thing here for sending messages, and then you have a display window for showing all the messages and blah, blah, blah. So whatever, and then whatever, right? So what would happen is in a blocking socket framework, so sockets that are blocking, what the term blocking means is they're going to block or lock or thread lock the main graphical user interface. So let's say that this is the other person over here. Okay, I know this is kind of stupid looking. There's their program. Okay, you're the let's say that you're the client socket and they're the server socket. So whatever, it doesn't matter in this case. They're over here. They got a button to chat with you, and they got a thing here where they're looking at all your messages. So it's just a basic chat program, right? So you click the button and you send a message to them. While you're waiting on them to respond, your entire app gets screwed. Yeah, like, you guys ever, have a program freeze up on you, and when you click around on it, it all goes, and it turns white and ugly and shitty looking, and then it says not responding in the top left-hand corner right up here. That's what it is. It's blocking the main VCL thread, the main graphical thread of your application, which means your app is frozen. Like it's not responding because it's waiting for data that it was expecting and it didn't get, right? So that's kind of what I'm getting at. So you guys, you might be wondering to yourselves, you might even be saying like, who the hell would want to program a rat or anything else for that matter with those kind of sockets? Well, here's the thing. Those kind of sockets are not a bad thing, believe it or not. You just think they are. They're really not. They're not bad at all, because when you think about it, let's just pretend that this is our IDE where we're programming. Okay, it's a big long thing with a bunch of code in it, right? Just a bunch of lines of code, blah blah blah. So a bunch of code in there. With event-driven programming, here, let me open this back up. You see this, how we have like on connect, on error, on read, like all of this can get a bit scattered. Like, see, this is in one area, this is in a different area, this is in a different area, and this is in a different area. All this stuff is in different areas, and it's all over the place, right? So it kind of does become a bit cumbersome, especially if you have a multi-million like line application that you're writing that you've been building for like 4 years or some crazy crap like that. It eventually becomes very troublesome, like with event-driven programming. So these non-blocking sockets can become kind of a pain over time if you don't manage them well. Now I know a lot of people disagree with that. I'm trying to be nice to the blocking socket frameworks, okay? But like with blocking sockets, everything happens in one block of code. You get me? So like this whole block contains every single piece of both the send and receive data, like in a way that's super, super easy to follow. You get me? So you don't mix and match up your code. You don't get lost in translation. It's just simple. It just is what it is. You just read through it until you find the part you're looking for. And it's super, super simple to find the part you're looking for. But with event-driven programming or non-blocking sockets, like the ones I've just showed you, like I told you, it's everywhere. It's sporadic. It's all over the place. Like, see, look, we got an event for connect, disconnect, on handle command. And so on handle command right here, this would essentially be considered the block where everything exists to receive commands and stuff. And if you have, it's like this with blocking sockets. So talking about blocking sockets, if you have blocking sockets, millions of things can't fire at the same time because blocking are non-synchronous. Okay, they're not async, they're non-synchronous, which means only one piece of code can execute at a time. Now this can happen super fast, so fast that it's almost nearly as fast as async sockets, don't get me wrong, but doing it can be a pain in the butt. You know what I mean? So when it comes down to these sockets, you can have data flowing both ways at the same time. But with these sockets, with blocking sockets, that's not possible. I mean, it can be made possible. Anything with code can be done. But the point is, out of the box, that's not how they work. Like, you have to send data this way and wait for this socket to respond with data. That way, both are caught up and are finished and won't freeze and block up and lock the user interface and et cetera, and not respond and all that crap, right? So if you're the person who sent the first piece of data, like from the server to a client, then your app would freeze. If you're the client and you send first, your app will freeze. You see what I'm getting at? If data is expected, it's going to lock up your application. That's why they're called blocking socket frameworks, because they block the main thread. You get it? They block it. So that's why blocking sockets, they freeze up applications, and a lot of people don't like them for this reason. A lot of people say they're evil. They're not. So let me pull this back up for you. Earlier we talked about this, but all of the indie sockets, so all of the indie servers and anything and everything in Delphi that has an indie tab, indie, like all this stuff, these are mostly all blocking, except for the UDP, because that one doesn't apply. But the TCP, the command server, client, everything, almost every bit of this is all blocking, okay? So this is blocking, and that's the client. So let's put that over here so it makes more sense. But that's a blocking server. That's a blocking server. And then if I look for indie clients, this would be a blocking client. This would be, whatever. So this one goes to that one. We can delete this one. But, so that this goes to this, and they're blocking. So if this one sends a message to this guy and he doesn't receive anything back, the application will freeze and it will start to turn white and look ugly and be shitty, right? But there is a workaround for this, and you guys are going to get a real kick out of this. There's a little workaround that the indie pit crew, the people that developed this this socket library, actually do to kind of mitigate that issue, so to speak. It's called an antifreeze. So this is an antifreeze, and you have to put it on both the client and the server. Isn't that great? It's actually got a little picture of antifreeze, like you'd throw it, like you'd dump in your car. But anyway, in your shit. So basically what this component does, from my understanding, and I could be wrong about this, but I couldn't possibly be too far off. Essentially what it does is it creates another thread for your main form that runs in the background. So that way, whenever the socket does send data and does try to basically freeze up your application, the antifreeze component's purpose, properly used, will create a sort of separate thread which manages kind of a fake GUI, I guess you could say. That way it gives the appearance that you're not actually froze, even though you are, but it just gives the appearance that you're not. And that's essentially what this is used for, I do believe. If anyone knows the actual definition of this, please put it in the comments. It's been a long time since I've messed with Indie. I read the Indie in-depth book, but it's been like 12, 15 years ago. So if you guys know the actual definition of that, please let me know. But I do think that is like a close enough definition to be correct. So anyway, I'll delete these out. So that's that. That is what a blocking socket framework does. So those are blocking sockets. Now let's go back and pull out this and get rid of all this crap. So just get rid of this, get rid of that. Okay, so now let's talk about, instead of blocking, let's talk about non-blocking sockets. Non-blocking sockets. Okay, so these sockets, also known as async sockets, or asynchronous sockets, can handle millions of requests practically every millisecond. Everything can be thrown both ways at the same time. So remember how blocking sockets can only send one way at a time and freeze until they receive something, right? So these, let's say this is a client, right? And this is a server, right? So these can send this way, this way, this way, this way, 10 million times. And it doesn't matter. This can send 2 or 3 or 5 or 10 messages to the client at the same time. It doesn't matter. They can batter it back and forth like they've got a couple of machine guns. This guy's got a machine gun. This guy's got a machine gun. They go and shoot each other all they like. It doesn't matter because it's event-driven programming, and the client and the socket or the client and the server socket can receive and send at any time without interference and with no blocking function, with no no worries of freezing the main graphical user interface is what I'm trying to get at. So a lot of you right now are probably thinking, well, holy shit, Bitmaster, that's exactly what I'm going to use because, yeah, I don't want to use blocking sockets. That's fine. I totally get you. I've actually worked with both a long time in the past. For the longest time, I actually didn't use async sockets. I actually used blocking sockets for a lot of different programs that I wrote back in the day. Some of them very, very powerful rats. Very powerful. Like knock your socks off powerful. I would show you one, but honestly, I moved into my new place and I have got a hard drive around here somewhere with it on it. I still haven't dug that out of my moving boxes yet. But I may try to find a GIF of it or something and put in the description if I can find it. But anyway, so you can, the point is, if you guys are sitting there debating, like right now, you're thinking, oh shit, man, I don't know what to do. Like, should I use blocking or non-blocking? Well, I'll just straight up tell you guys, if it were me starting out today, I would just go ahead and use the non-blocking, these right here that I just taught you about. So that way they're async by default and you don't have to do any extra programming under the hood or whatever. So personally, I would just stick with everything I just showed you. I would just stick with these. These are old as piss. I would not stick with them at all. But I would stick with Netcom 7. Netcom 7, and there are countless other libraries, guys. I mean, I'm telling you what, guys, there are so many libraries out there available. It'll just blow you away. Like, so you don't have to stick with any library you don't want to stick with. You've got to find the library that best suits your needs. And for me, ultimately these days, that's Netcom 7. A friend of mine and I, we've done some amazing stuff with the Netcom 7 socket library. So I highly recommend that you guys use these as well. Now, if you don't have these installed, which you really shouldn't, you probably just watched me write this, but if you want to get these sockets installed, it's actually quite simple. Let me show you how to do that, okay? So what you'll do is you'll go to, here, let me just type in google.com, netcom 7 sockets, and we're gonna go here. So you just go to the GitHub page for Netcom 7, and you would click code and download the zip, okay? So, and I have a customized version that a friend wrote, which I'll leave that link in the description so you guys can get the updated copy from him. But this, you would download the zip and download it to your computer, okay? So I'm not going to do that right now, but if you go into the IDE, I'm gonna close this out. So let me not save that. I'm not saving any of these guys. I'm sorry. I don't need to save this. Ultimately, you can design and follow along and remake this yourselves. It's super, super basic. It takes almost no effort at all. So in order to get them installed, here's what you have to do. So let's say that you downloaded that zip file from GitHub. You want to save it on your computer somewhere. I saved mine in a very special place on my C drive. So what you'll want to do is go File, Open, go to your C drive, and then you'll go to your Components folder, and you'll be able to find the Netcom 7. So mine is actually going to be under my socket components. I like to keep everything organized. So just go into Netcom 7 master, which is the folder that you should have downloaded from GitHub. After unzipping, it'll say Netcom 7-master. You'll come in here and you'll see netcom7.dproj. That's a Delphi project, okay? So you're going to open this one right here, netcom7.dproj. So click on Open. Now, you're going to notice that mine's already installed, so it has a little different color than yours. But you see this little BPL file thingy right here? Mine, the little thing shows green because I've already installed it. Yours will be like a brownish or weirdish hue color. All you have to do is click on this, right-click, compile it. A little window will pop up and it'll finish compiling and all that. Then you click OK on that window, right-click it again, build it, and do the same exact thing. A little window will pop up, click OK on it. Then right-click on it again and click Install. Now, if done correctly, you'll get a window showing you all the components in the middle of the screen that it installs for you, and then you'll just hit OK. If you get an error, for any reason, if you get an access violation or an error or anything like that, don't freak out. Just close the IDE, reopen the IDE, and try again. Go File, Open up the dproj file, right-click on Netcom 7 BPL, and click Install. And it should work, okay? So that's how you install Netcom 7. Then, let me show you this. Then after you've done that, you can close out of everything. And when you reopen a new project in Delphi like this, you can type in server S, and you'll see Netcom 7 tab there. So you'll see the Netcom 7 tab, and you should have all these components here, just like this, lined out. Okay, and there's a TCP server, there's a TCP client, there's a UDP server, UDP client, server source, client source, command handler, and then a database server and some sort of database data set. So there you have it. Those are all the Netcom 7 components. All right. When you click run, now let me be very specific with you guys. Okay, so you need to be paying attention. If you run this program, so I'm going to run this. If it runs and shows up on your screen like this, you're great. You're doing okay. Now don't freak out, because every single one of you is probably going to have this problem. So pay attention. When you click run, if it gives you an error, okay? If it gives you an error, you're going to have to do this correctly. You're going to have to figure this out. So let me pop this open just real quick. Just bear with me here, guys. My computer's kind of lagging up on me. So guys, you see this right here? This is my Netcom 7 master folder. So if you get errors because it won't compile and run your program, you have to do the following. You have to browse to this folder, okay? Just stick with me. It's super, super simple. You just browse to this folder called Netcom 7 master, and then you can go to source. Okay, now once you're inside of here, there's two folders. There's this one that you're currently inside of, which is called source. So you need to take this whole thing, this whole path to this folder, copy the whole thing. All right, just copy it. And you're going to go back to the IDE, tools, options. Then you're going to type in the top right, library path. Then you're going to click on library path. Then you're going to click on the top ellipsis button. Make sure that the Windows 32-bit platform is selected, okay? Then you're going to click on this top ellipsis button right here, this library path, top right little ... ellipsis button. Click on that. Then you're going to erase this bottom piece and click backspace. Then you're going to hit paste. Okay? Then you're going to hit the add button. Mine's grayed out because I've already added it. So don't freak out, okay? But you guys are going to add that path. Then you're going to erase this path. So after you click add, and it throws it up in here somewhere, then what you do is erase whatever you've got written down here. Just erase it out, make it blank, go back to your folder, and double click on the encryption folder, okay? Then you copy that path, okay? And you're done. Just paste it in here and click add. Then you can click OK, and then you can click OK again, or save, or whatever you want to do, or just make sure to hit save, okay? And that's it. Then you can click run, and it will run without any errors, okay? You follow me so far, guys? Super basic, simple stuff, right? All right, so now that I've got past all that, guys, I think this is actually coming in pretty close to being good. Man, I've really covered this pretty well. I really hope for you guys. So, yeah, this is pretty wild stuff. So you guys are now basically more or less caught up. You should understand what sockets are. Clients connect to servers with an IP and port. Server listens on a port for connections to roll in. You've got blocking versus non-blocking socket frameworks that you can be using. I've shown you how to create a simple chat program with two different types of sockets. Netcom 7 as well as the basic T client socket, T server socket, which ship natively with every version of Delphi since version like probably 1 or 2 or 3 or something like that. Okay, so guys, ultimately this has been an introduction to sockets and network programming in the Delphi programming language. So I really hope you've enjoyed. This has taken 2 hours, over 2 hours to like just kind of do this. I tried to be as specific as humanly possible for you. I really hope you appreciate what I'm doing. I really hope that you guys can follow this and that it's super, super basic and simple for you to do. I'm sorry if I did get a couple of things out of place, like installing these, because you guys are probably just sitting there watching me do it and you guys couldn't get it installed for yourselves. I'm really sorry about that, but at least I got the first one done. That way you guys could get the client and server socket installed and follow through with that one. So, and really that one's actually a lot more fun because it's just more basic and simple to set up and get going. But in any case, I think at this point we're going to go ahead and call this video, and in the next video, let me let me close out of this. Let's take a quick gander, just real quick, at where we're at in our YouTube rat. So this is actually looking pretty darn good. So in the YouTube stuff, in the YouTube rat, starting with the next video, I think we're going to go ahead and implement the networking into the rat. In other words, we're going to take the knowledge that I've given you from this video, and we're going to apply it to our rat. And we're going to start programming stuff back and forth between the server and the clients. Starting with, I believe we will do the task manager first, just because it can literally be done in about 2 minutes, maybe less. Definitely, for me to explain everything, maybe like a minute, minute and a half, maybe, I don't know. But we're just sending basic text back and forth. So this is going to be really, really cool. And we're going to theme it. We're going to put a task manager icon, and we're going to do all this cool, crazy stuff. So it's going to be really nice. And again, I'm also going to show you guys some advanced techniques for cloning forms, etc., etc. So basically, just go ahead and kind of let this sink in, what we've learned in this video, and take some time to let that seep in, and let it kind of fester in your mind, if you will, you know, and let it grow and turn into some terrible fucking malware. I'm just kidding. Just kidding, guys. Just kidding. Okay, but yeah, so that's pretty much it. I'll see you guys in the next video, where we're going to take the knowledge from this video and apply it to the networking of our rat. All right, guys, I will catch you in the next video. Until then, keep practicing. Maybe even write your own chat program or something. Make it cool. Give it a good theme. Oh, and by the way, you might make a chat program, compile it, and build it. Oh, and you know what? I'll tell you what. This will actually be something to look into. Check this out, guys. If you're looking how to make an exe in Delphi, I know I never really showed you guys this. Just select this little down box thing here and select the release mode. Then right-click on your exe and left-click build. Once it builds, you'll be able to right-click on it again and go show and explore and go into Win32, release, the same mode that you built it with. So it'll either be debug or release. Make sure it's on release before you build it. Go into release, and there is your exe. So I can double-click this, and then there's our rat, you see? So I just wanted to show you that, so you'll be able to deal with that, okay? So now you can take this knowledge and go build a chat program, build the client and the server separately as two separate EXEs. So you'll have to open up two different IDEs, like say this would be the server and this would be the client, and then you would program a chat back and forth between each other, right? So you could build the chat and the server to EXEs, give your friend the client, and give yourself the server. Then you can run the server and they can run the client. Make them connect to your global IP address, and make sure you enable port forwarding on your router. That way you can receive data packets from your friend. And you guys can chat over the internet via your chat program that you wrote in Delphi. Pretty cool stuff, right? All right, guys. So that's that. Food for thought. Just you might practice around a little bit before proceeding to the next video. We are going to get involved in the next video into implementing networking directly into our rat. To reiterate, we will be going into a little more depth, okay? So like with this type of thing, we're not going to do some basic text back and forth. That's not what we're going to do. We're going to take it to the next level. So even though some of it may be text, we're going to have to manage our sockets properly. And that's what I'm going to be teaching you in the next video. So take your sweet time to try to figure out how to write with sockets in the Delphi language. And once you feel comfortable enough, you can proceed to the next video where we're going to be working directly on our rat project, okay? All right, guys, I've talked enough, probably talked your ears out. So I'm done. I will see you in the next video. Until next time, peace out. Check you later, guys.